In this video we will be reviewing 5 questions that pertain to Target 4C. We'll start with question number 11, move to question number 12, number 13, number 14, and finish up with number 15. So to begin, let's start with question number 11, and that's dealing with average rate of change. We're given a graph where we need to find the average rate of change that is -8. And the key word here is negative. And that means that our interval is going to be somewhere on the graph where our y values are decreasing, which is going to be right here. I just highlighted that. And we have 2 points here, 3, 2 and 4, 0. So let's see if the average rate of change there is going to be -8. And recall that the average rate of change is rise over run. So we want the vertical change first. So from this point moving down to this point here, how much did that vertical change? Well, we went from y equals 2 to y equals 0, so that only changed twice. And because we are going down, we'll just say that's negative. And then from this point, the x value, to this point right here, where the x value is 4, we went from 3 to 4. So that change was only 1. So the average rate of change between these 2 points is going to be -2 over 1, which is not what we want. So now I'm going to call out this point down here we're given, and that point is 6, -16. So again, we're going to check the rise over run from 4, 0 down to 6, -16. So let's go ahead and figure out what our change in y was. Up here we had a y value of 0 that was given in this point. So we're going to move down to where we have -16, so we go down by 2's. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16. So our vertical change is going to be -16. Remember, it's negative because we're going downwards. And then how much did we move forward? So this x value was 4, and then this x value was 6. So we went from 4, 5, 6, so we moved forward twice. And -16 over 2 reduces to be just a -8, which is the average rate of change that we were looking for. You could have also done this by just using the slope formula, where that's going to be y2 minus y1 over x2 minus x1, which could work too, but because we're given a graph, I figure it's easier to just use the graph. In question number 12, we're given a table here. We want to figure out the average rate of change between where x equals -2 and x equals 2. In this situation, we will use that slope formula, which is going to be the y2 minus y1 over x2 minus x1. So there it is right there. Now I want to call out 2 points that we could use for this formula. So first of all, our x is going to be -2, so right here on my table, that's where we have x equals -2, and that's partnered up with this f of x value, which would be y. So that point is going to be -2, 5, which will be x1 and then y1. And then our other x value is 2, so that's going to be down here, and that's matched up with a y value of -3. So there's my x2, y2, it's going to be 2, -3. Now, does it matter which point you refer to as x1, y1 or x2, y2? No, you'll get the same slope in the end, so it doesn't really matter. So now I'm going to go ahead and take my values and plug it into my formula. I'm going to start with my y2, which was -3, and then we're going to subtract my y1, which was 5, and then we're going to divide that by x2, which was a 2, and then we're going to subtract a x1, which is -2. So I'm going to go ahead and do that. Put that in parentheses there. Now -3 minus 5 is going to be a -8, and then a 2 minus a -2 is going to be 4, which simplifies to be a -2. And that's going to be our average rate of change. Or you could actually write this as a fraction as well. You could do -2 over 1. That would work too. Okay, on to question number 13. We're given a graph here and we want to figure out the interval that represents the greatest acceleration. So that just means which of these intervals right here do we have the greatest change in y, I guess you would say. Now remember that rate of change is measured by rise over run. So from 0 to 1 here, we only went up 1. And then from 1 to 2, we went up 3. And then from, from 2 to 3, we went up 5. So it's going to be 1, 2, 3, 4, 5. You see that here. That's going to be your greatest acceleration, because these are all moving forward just 1, so you could write 1 over 1, 3 over 1, and then 5 over 1. So again, this is going to be your quickest acceleration. Question number 14 asks us to graph a function here. And instead of me struggling to do an accurate graph right here, I'm going to go ahead and graph this on Desmos and then move in a screenshot of that. So here's that graph here. And we want to figure out, first of all, the average rate of change of the function from x equals -2 and x equals 0. So x equals -2 right around here, and that's going to be -2 comma 5. And x equals 0 down here, and that point is going to be 0 comma -3. So we're going to use our slope-intercept our slope formula, y2 minus y1 over x2 minus x1, to figure out this average rate of change. So I'm going to treat this point down here as my, I guess you'd say my second point. So that's going to be y2 and then x2, and then this one up here is going to be my my first point. That'll be x1 and x1 and y1. So I take y2 down here, which is -3, and I subtract y1, which is going to be 5, and then I take x2, which is down here at 0, and then I subtract my x1, which is going to be up here, a -2. So -3 minus 5 is going to be a -8, and then 0 minus a -2 is going to be 2. Our average rate of change is going to be -4 from this point to this point. So that's the interval -2 to 0. You could have also done it just by looking at the graph. Starting at this point, we move down 1, 2, 3, 4, 5, 6, 7, 8. So it would be down 8, so -8. And we move from this point forward twice. So 1, 2, and -8 over 2 is the same thing. It's -4. Either way really works. Now B says we need to sketch this graph. We already have it, and it wants us to draw a line segment connecting where x equals -2 and x equals 0. So we already have those points called out. All you have to do is draw that line. So that line is going to come down from this point and hit this point right there. So that's done. Now it says, do the calculations in part B, or maybe that's referring to part A, represent the average rate of change for the entire function? And that is not the case, because from this point we moved down. So like I said, we went down 8 and then forward 2. So that average rate of change, like we calculated, was -4. But if we follow the parabola from this point, we're going to start going up again for our y's, right? It goes down and then it comes back up. So then, for example, if we called out this point and maybe this x-intercept here, this average rate of change is going to be positive because we're going up. So obviously it's not going to be the same as -4. The only time that your average rate of change would really be identical for the entire function is if you had a line. So on to question number 15. We're given a graph here. We have it seems like a ball going through the air. You have your height here and then your time here. And we want to figure out average rate of change between x equals 0 and then x equals 1. So x is going to equal 0 right here, and then x equals 1 right here. So what was our average rate of change between these 2 points? Well, remember that we said rise over run would represent our average rate of change. So the change from this point going up is going to be 1500. So I'm going to write 1500, should be 1. And then that's going to be over, well, how much did it run forward? Well, we went from 0 to 1, so that's just going to be 1. So that average rate of change is going to be 1500 over 1. In B, it's looking for the average rate of change from 1 to 2, so x equals 1 here, like we already mentioned, and then our x equals 2 right here. So again, rise over run, we went from 1500 to 2000. That difference between these two is going to be 500, and then that's going to be divided by our run. So we went from 1 second to 2 seconds, so again that's going to be 1. Now part C asks us to interpret these varying rates of change. So it looks like at the beginning, from 0 to 1 second, we were increasing at an average rate of change of 1500 right there. So as we got farther along, we went from 1 to 2 seconds. It seems like our ball's kind of like leveling off as it approaches the maximum height. So then it kind of slows up a little bit and it's getting ready to fall back down to the ground. So that's why we have a slower average rate of change. It's only going to be 500 centimeters per 1 second. Now let's go ahead and recap. Question number 11 was looking for the average rate of change between 2 coordinates. Question 12 was looking for the average rate of change, and we had to use a table. And then 13, we were just simply looking at this graph and trying to figure out where the greatest acceleration was, which was 5. 14, again, more stuff with average rate of change, and then it asked us to justify some of our reasoning down here. And that's because we were trying to figure out if the average rate of change would be consistent for the entire parabola, which it wasn't. And then lastly, number 15, we were just comparing the average rate of changes between 0 and 1 second and then 1 and 2 seconds. And that's it.